Hello, welcome to this tutorial on processing by examples. So in this tutorial now we will be seeing how we can use processing uh, for different applications, and for each application we will be seeing an example, description of the example, how you can compile and or run the processing application. Okay, so let us take our first application. So here is a simple application where we are trying to draw a bunch of objects. So in this case we are trying to draw a rectangle, ellipse and a line, and we define the size of our window, a processing window, as 300 by 300. So in order to so I'm gonna go and I've already have this, so you can go to my sketch. As you can see, we have this setup function which defines the size. So we need to draw a rectangle with the centers there and the length and the width. We draw an ellipse again with center 200 by 200, x and y axis, and with A and B as 40, so it's going to be a circle. And then we're going to draw a line from 0 0. Usually the origin is the top left hand corner is generally referred to as the point 0 0, and the bottom right hand corner is the maximum pixel point, which is 300 by 300. So the compilation of the run process is simple. So we just have to click on the run button, and our first application, as you can see, is created. So we did create it from 100 100. So we created a rectangle, and then that's our ellipse, which is nothing but a circle, and the line which we drew. So if I'm interested in changing any of these values, you can see I go, let's say I want to do this at 200. I want to create really an ellipse 70, and I now want to use the line is 50, and I'm just gonna recompile it or just rerun it. So here you can see how things have changed. So here you can see that's the A and the B. So now it's the ellipse is 40 70. The line, actually we started from 50 0 to 300 300, and then our rectangle also, instead of being from 100 100, it is now moved to 200 100. So using this you can actually even draw complicated objects. You can also throw in the curve function in other functions, vertices and so on and so forth, and draw good graphics. Alright, so that concludes our first application. Our second application, which we will see, is how we can do a mouse interaction. So here, as you can see, this is the code for the mouse interaction. Again, we defined our size of our window. So we say that the size is 600 by 300 pixels. We need to have a background color. So now what happens is, whenever the mouse is pressed, I try to use the fill command, so that the object I draw is going to have this color. So it's going to be fill, and it is only having a random G component. So it is going to give me some form of magenta or pink and so on. And here you can see I'm going to draw an ellipse, which is going to be centered where my mouse is, and it's going to have a radius of 30. So if I press any of the keys, let's say the Y key, and then what happens is, as you can see, I'm now changing the color. I now have a random color for my R red component, and so that will give me various shades of blues. And again, I'm just going to draw an eclipse with again with the center where my mouse is actually pointed to. So for this particular application, as you can see, I have say mouse demo, and there you can see this is our sketch of processing. So I can execute this, and as you can see, if I have my mouse, this is the background, which is 170. So if I'm not pressing any keys, so I'm going to drag. As you can see, that's my so now I'm going to press my key, which is Y, and if I try to move the mouse even without pressing it, because here the key is just pressed and I don't need to press the mouse key, so you can see I'm executing the second part of it. So therefore this is a very simple application where you know you are trying to use the position of the mouse and create interactive application. Our third application is on image processing. So we see two image processing applications, but the first one is relatively simple. So as you can see, our image processing example here is we are going to take a particular image. So we have a setup function, we read a particular image, and in the drop function we are again going to use our location of the mouse, and based on the location of the mouse we are going to adjust the brightness of the particular image in that region. So the rest of the region will be darkened. So wherever the mouse is, the region around it so it will be brightened. The rest of the pixels will be darkened. So this is a very simple application that based on processing. So as you can see, that's our image, and we already have. So whenever I move my mouse, and you can see my image gets brightened. If I all other places it is darkened. So it's a very simple application which describes an image processing application using processing. Our next example would be to handle strings. So as we have seen earlier, we can read a particular text file using the load string and write to a particular text file using the save string. So here is an example which we will see. So our application, the next one we will see is about string processing. So here you can see that in the string processing we are trying to read our data from a file called data.txt and by the load string option, and the variable or the array stuff is now going to have the data, which is a comma separate data, is going to be pushed into an integer array again. And then now we are going to again manipulate this and fill or give it like a bar chart kind of representation. So when we try to execute this, so here you can see that's our data, and these are the different bar charts representation. So this is an example of a string processing. So our next is to use the displays. So to use the displays, again here we are going to read and display to a chart. So you can take another example. Let's say this. So here you see that we have a float table data. So that is defined in this particular file. It is a class. So it contains row count, column count data, row names, column names, and so this is nothing but a class. So we define that. We have a tab separated file, which is shown here, and as earlier you can see that we will be able to read the data from this file. As you can see over here, we will read it, and then we will split it based on the tab. So every data is tabbed, and then we prepare it to be parted on the X and the Y axis. And also currently we are not giving any labels, but you guys can try out giving labels. So executing them, you can see that that's the data which is shown, and that's an example of the display. The next application is you can also use URL processing with processing language. It's relatively simple. So go to an example, sketchbook, and say here's our example. So here what we're trying to do is we are now going to specify a string which is URL, and we can also load the string as an URL. So it does go fetch the particular text file, and in this application it is going to go through the file and see for the delimiters, which would be nothing but the delimiters are spaces, commas, dots, question marks, exclamation, semicolons, colons, brackets. All these are delimiters. So it's going to split this, and it is going to give us what is the rate of occurrence of every word. So, and totally how much times did it occur. So if I execute this code, as you can see, you will have a demo. As you can see, there are different words which are occurring in that document, and this tells you the frequency of occurring of those words. So our next application, as you can see, is based on a library. So we have an AR library which is found in the processing website. So we have already completed a tutorial on how to install processing libraries. So if you have any questions, please refer to that particular tutorial. So in this case, as you can see, we are trying to use a pathfinder. So we are going to use a Dijkstra's algorithm to determine the shortest path between two particular random points in a maze. So our processing application starts by inclusion of our library, and here you can see we have a code which again has a setup function, and then our draw function, the setup function, initializes our pathfinder command, and so it says every time a mouse is pressed what action needs to be taken, how to draw the connectors, and how to come up with those random points. So by executing that, so now you can see, so that's the different locations there. So every time we press a particular mouse button, between it shows the shortest possible distance between that point and all the points in the grid. So here is our second application here, where we have an A-star algorithm. So here again we are trying to determine the shortest path between two particular nodes on two particular boxes in our application using A star algorithm. So here again it starts by inclusion of the library, then we define our pathfinder algorithm. So that's the demo of the A star algorithm. Definition of the library. We defined our instance, and it tells us when a mouse is pressed we get a random node, and get two random nodes A and B, and then do the A star um, algorithm to find out a path between these two nodes A and B. So as you can see, the 2 points are connected, A and B, and that's the shortest path. That's our second. So every time a mouse is clicked, we identify 2 points A and B, and the shortest path from A to B is actually computed by the A star algorithm. So here again we are using a breadth first search demo. So here you can see that you can also include some animation. So what we have done is that is setting up of the grid. Whenever a mouse is moved, uh, uh, a ball basically tries to reach the mouse using the breadth first search. So you can see that's the code for our breadth first search. So it reaches the target. So compilation and the demo, as you can see, so there exists no path, so therefore it is not unable to reach, so it reaches to the closest possible block. So our next application is on real-time image processing. So as you can see, we are now going to process the video, and we're going to detect some blobs in a particular image, so which was captured using our web camera. So the application demo is actually given here. So as you can see, we are using a library for blob detection, so that needs to be installed. That's the only variable that needs to be adjusted for the luminosity. So depending on the variable you assign there, the blobs detection algorithm is going to detect under different threshold. So here you can see is a live snapshot where the different blobs or darker shades are being detected. So in this session, the next session, we will be talking about how can we make processing and talk to each other.